Okay, this is now another example, second example for this alpha beta pruning. And here you don't have to think too much about the details of the algorithm. Here you have to do just tick, 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 tick like that, and then you will have your values. For example, this tree will be given to you with the starting alpha and beta values, which is minus infinity and plus infinity. Okay. When it is not mentioned, it is plus infinity. A, B, C, D, E, F, and these are the terminal values. And here, this is the max player, this is the min player, this is the max. And you know what is the function of the max and what is the function of the min. Min will take minimum, max will take maximum. So from these two, now if you will look over here, from these two, this is the level for the max. It will accept the maximum value. Okay, it will compare, and then 3 will go up here at this node. When 3 will go up here, this is the level for the max. It is not the level for the, it is not, it is not the level for the min that the value of the beta will be updated. No, it is the level of the max. So then you have to think, so the value of, then what? The value of alpha is updated because alpha is the variable for the max player. So this 3. And similarly for here, now, and the value of the beta is still, value of beta is still uh, the plus infinity. And then now it is DFS, so you will go like that, huh? You will go like that, huh? So now when it is finished, you will go here and this information will go up here first, and then you will come in this direction, huh? So this information, this 3, where is, oh, so this information, which is 3, this information will go up here. And now this is the value for the min. So from here, min can get only the value 3. From this node, this is the level for the min. We have to think for this b. From this node, this b can only get the value 3, which is the value for the alpha. But from, we have only one node, so that's why up. So after executing this whole branch, the value of beta for the minimum player is also 3. If you will have some minimum value next, you will update the value of this beta. But take this, that the minimum, the min player can have the maximum value, the value 3. Alpha is no doubt 3 up to this point. And now we have, according to the depth first search, we have to execute this. And when you will execute this, E, now what will happen? The value of the beta is now 3. And when you will open it, 5, you will have the 5, 5. So from here, but now first think, you have one level for the max player. Max player will compare these two, and it will take the maximum, which is 9. It will take the maximum, which is 9 here. It will, but this min will not accept this 9. Because min has what? 3. Min has 3. So from here, the max will take 9 from here, but min will not accept here. Yes.
Prune 9. 5 is greater than 3. So it will prune 9.
Yes. After looking at 5, only then you can decide. Otherwise not. What you have to prune, okay? So, but what I am saying here, that for example, if you will execute it, then you will have 9. That is not needed. Even 5 is not needed. But how you will decide? According to the algorithm, yes. You have, when you will open up this first branch, it will be 5. 5 will become here, and that 5 is not needed here by the min. Even you have some lower values, but this max will not accept the lower values. Again, so up to this point, you have the value of beta 3. Now, when you will come here and when you will open this branch, first branch, you will have the value 5. Okay, the max will have that value 5. Max will have the value 5. This is not opened yet. This is not opened yet. So the max will have 5, but this 5, this min player will not accept. If you have some less value than 5, 4, 3, 2, 1, then this max will not accept. Then if you will think all the options, if you will have some values 4 after this 5 in the next node, if you have 4, 3, 2, 1, then this max will not accept because max already have the 5 value. And if you have higher values than 5, 6, 4, 5, whatever, higher than, then max will accept, but min will not accept. So from this whole discussion, after opening this first branch, you know that the next branches are not needed to open because beta has already 3 and it will not accept any higher value than that 3. So that's why the pruning will occur, which you are seeing here. The pruning will occur, and here 5, the here the max value, which is alpha, it will become 5. But your beta is already 3. So after that, due to this situation, when you that discussion is mentioned here. That discussion is mentioned here. So due to that reason, we are not going to open it. We are not going to open it. That whole discussion is mentioned here. I can read it, but I'm just when you will see that it will be when you will discuss the lesser values and the higher values, then the things will become clear in your mind. Now, so now up to this point, 5, okay, we have 5, but this 5, this min player will not accept. So up to this point, what will happen now? The minimum value for the min player is still beta. Still beta. So up to this point, the beta. Now, if the beta is 3 here, if the beta is 3 here and alpha is minus infinity, now think for this A. Now we have to move on the other side by using the depth first search. But these values will be propagated back up to the root node. How? So this is the turn for, this is the move for the max. And up to this, value 3 is there. So the max, so the value of max can be 3 maximum only by using this tree, which is mentioned here. So that's why it is alpha is equal to 3 mentioned here, due to this information, due to this information. And now we are going here. Your alpha is 3 and your beta is what? Positive or plus infinity, which is this information. And now when you will go here on the C, you cannot decide anything. You are taking this information also with you here. When this information is available at the parent node, that information is also available at the child node due to that algorithm, alpha beta pruning. Due to that alpha beta pruning algorithm. Okay. So according to the depth first search, you will go there, then there, and when you will come here, when you will come here, here you have the value 0. Here you have the value 0. The max has the value 0, and here the max has the value 3. Which is now you are taking this information with you. Alpha is equal to 3, alpha is equal to 3. And here the max has the value 0. You will not get this. You will not get this. So then what? So then what? You will do what? Here, you will open this branch, because this is lesser value. Maybe you will get some higher value. So max player already has 3. So here you are getting 0. So you will open it. It is 1. And it is 1. So again, you already have 3. Okay. So Up to this node, you can have this value 1, but you are not going to accept this one value. You are not going to accept this one value for the max because max already has value 3. Then, okay, you are going back, which is mentioned here. So up to this node, you have 1. So you have up to this node, you have 1. Now this is the move for the min player. Min has the variable beta. Min will want this value. Huh? The min will want this value. Min will want this value because now one branch is finished. And that's why we are mentioning it beta is equal to 1. Beta is equal to 1 and still alpha is equal to 3 by that parent information. By that parent information. Now think over it. If now think over it. If you have 1, you are here, your alpha is 3, your beta is 1. Your beta is 1. If if your beta is higher from this whole thing, if your beta, because here this is the move for the min player, if your beta is higher than 1, if your beta is higher than 1, then maybe you are not going to accept it. But if your beta is 0, then you can accept it, huh? Then you can accept it. Anyhow, and think over it. Just a minute. Shift. So now think over it in general sentences. When you have this situation after executing this branch, when your alpha is 3 and beta is 1, now you can imagine that if you will get some value from here for the max, for the node G, which is the max node, huh? If you will get some value higher than the alpha value, huh, which is 3, if you will get 4, 5, 6, 7, 8, it is possible. It is possible. But your min has the value 1. Your min player will not accept that value because it has the 1. If you will have 4, 5, 5, 6, 7, whatever, min player has the value 1. It will not accept those 4, 5, 6, 7, 8, 7, 8. Are you understanding? Again, what I'm saying, up to this point, your alpha has the value 3 and your beta has the value 1. Beta is the variable for the min player. Alpha is the variable for the max player. So it means that your max has the value 3. If you will get some higher value than 3 for the max player, it is acceptable. Huh? It is acceptable for the max. And here for the beta, which is the min player, it has the value 1. It will try to minimize the value. And it is possible that from this node and from this node downward, you will get some higher value than this 3. It is possible. And if you will get some higher value for this max player, if you will get higher value than this 3, 4, 5, 6, max player will accept that value happily. But at the same time, your min player has the value 1. If you will get some higher value from here, your min player will not accept it. Will not accept it because it has the value 1. Min player can accept lesser value than 1, but not higher. So due to that reason, there is no need to open up this branch and that branch is filtered out. Because if you will get some higher value for the alpha, this min player will not allow. So that's why this whole branch is pruned away. That's why this whole branch is pruned away due to this condition. When you will read it, you will understand it from here, okay? But I have explained it in general words. I have explained it in general words, what is happening here. what is happening here. Okay, and now this is the final situation. Actually, this is the final situation. Okay, what you have here, your alpha has 3, your beta has 1, the, up to this point. So, and here you can see that this 3 is coming from where? This 3 is coming from this branch. Here we are only showing that this 3 is coming from this branch. And what are the branches are pruned away? What is the value? The you can show the value of alpha and beta here, which is 3 and 1, which is 3 and 1. If I want to say you give me the values of alpha and beta here, then this is 3. And if you will think over here, the max player will get the value from 3. And here, if it is 3, then you will get the value 3 here for the alpha. Or suppose if from here, if the min player will get what value? Only 1. Hmm? From these two, this is the turn for the min. From these two values, min will accept 3, which is written here. And for the min player, from these two, whatever, here it is pruned away. So there is not 2, okay? Only 1. And that is 1 is here. And from that 3 and 1, for the max, the value is 3, which is mentioned here. Which is mentioned here. I just want to ask you, this is again according to that alpha beta pruning algorithm. This is again according to the alpha beta pruning algorithm. But I don't know, maybe I have taken some breaks in it. So how many students have the understanding of this example? Please raise your hands. Of this example, this last example. How many students? Only 1, 2, 3, 4. So half of the class has not understood this example. And why you have understood this complex one? This is the same. This one and that one is the same, no difference. No difference. Here I was running that thing according to that algorithm, step by step, step by step. The example was a little bit shorter. So that's why. Here you have to think by yourself. That's why you didn't understand. Here you have to think by yourself. Just a quick recap, you can say. Starting from here, the starting alpha and beta values are this, minus and positive, and these are the leaf nodes. I will go directly like that, and like a depth first fashion. And here I'm going from this 2 and 3. This max player will accept, max has the max, will accept the maximum value. First it will be 2 and then it will be 3, but I am skipping some steps. Okay. But when you will open this up, the value of beta will be what? The value of alpha will become 2 first. And when you will open it up, then it will become 3. But I am skipping that one, that 2. I'm saying when this branch will be done, the value, this is the max. Max is alpha. So the value of alpha is 3, which is going up. And here it is the level of the min. So now this alpha is becoming, this value is now becoming the value of the beta, because min has, here in this diagram, you have to think with respect to min and max player. Okay. Then maybe you will understand it better way. Here, this is the turn of the min player. So what value min player can get from here? There are two values, 3 and infinity. So some minimum value is what? 3. So that's why the beta will be 3. Beta will be 3. Now, so beta is 3. And now alpha is, from the previous information, alpha is minus infinity. We are at this point. And when you will open this E, and when you will open this first branch, that is 5, that 5 will go up here, which is the information for the max player, which is the information for the alpha, which is the information for the alpha. So this 5, this is 5, but this B node has the 3 value. This minimum min player will not accept that 5. This min player will not accept that 5 higher value. Min player already has that minimum value. How it will then accept this 5 higher value? So that's why after opening it, then there is no need to open up the further branches. And then you have the 3 value here, and then you will move this information up to the root, and then here this is the max player. So then alpha will become what is the value of alpha here from this previous information? 3. And then the other information for the beta is what it is, as it is, which is plus infinity. This information will go here. And you are following depth first search, so okay, this information will go here. What is that information? Alpha is equal to 3, beta is equal to plus infinity, which is mentioned here. Alpha is equal to 3, beta is equal to plus infinity here, and then we are copying this information here. And now when you will open this branch, this is the move for the max. So already max has the value 3 and it is 0. Max will not accept. Max will not accept. So, but still there is a chance that you have some higher value for the max. So then it will open this next one. But, and it is 1, and it is 1, not higher than this. So, but max will not accept it. So the value of alpha will remain 3. Or you can say after opening it, as you have opened all the branches of this node, so then what value you can get here? You can get here the value 1 only up to this node. But max already has 3, so it will not be accepted. Let's see it further. So, but suppose now, so in the min, now this is the move for the min player. Max player will not accept because it has already 3. But this min will accept this 1. So if it will accept this 1, then min has the variable beta. This is theoretical discussion. This is theoretical discussion. In the figure, the values are theoretical with respect to theoretical discussion. In algorithm, these values can be different, okay? If you will execute algorithm, these values can be different. Anyhow, so alpha, or so now this is the move for the min. So from by opening all these branches, we have seen that we are getting maximum value 1 for this max player. And this value can become the value of the min player at this level. So that's why we are writing beta is equal to 1. And now here, and now here, now alpha, which is the value for the max, and now beta, which is the value for the min. There is a chance that if we will open these branches, there is a chance that we will get some higher value for the alpha or some less value for the beta. And this is the move for the min. There is a chance. We already have the values 3 and the 1. But suppose if I will open it up, and if I will get some higher value for the alpha, which is 4, 5, 6, suppose, put it in your mind that you already have the value of alpha 3. But suppose if you will open up these branches and then you will get the value for the alpha 4, 5, 6, 7, whatever, higher values, higher than 3. That higher than 3 values will come here at the node G. Huh? But this min player, which already has the value 1, will that min player will allow those higher values to come here? No. Min already has the value 1, minimum value 1. And if the max, and here at the max player, if you will get 4, 5, 6, 7, min will not allow that value. Okay? Because min already has the value 1 by due to this branch. Due to this branch. That is the reason that we don't have to open it up. That is the reason that is becoming filtering out this branch. And what it means that we have, it means it means finally, if we are not opening it up, then this 1 is going here. The min will take this what? This value 1. And from this previous 3 and this 1, the max will take what? Maximum value, which is 3. So here we are writing the single values. And this is the last diagram of yours. How many students have now understanding of this example? Raise your hand, please. I'm not asking forcefully, okay? You have to raise your hands honestly. If you have understanding, then you can raise your hand. If you don't have the understanding, then be in that state in which you are. So now I'm asking again, how many students have the understanding of this last example? Raise your hand, please. Okay, good.